Hello. We are going to be talking about 2.5 problem solving. So let's do this. I believe we've talked about the 6-step process to solving application problems. No, have we? We may not have. This might be the first time. Okay. Here's the 6-step process to solving application problems. Step 1, you want to read the problem. Pretty obvious. What's helpful as you're familiarizing yourself with the problem is drawing a picture or a chart or a table or some way of visually representing the situation. Once you have the problem, you need to decide what you're going to have your variable be. What are you trying to find out? Usually your variable is going to be the thing that you know the least about. So step 2, assign a variable. After you have your variable, what you're going to want to do is write an equation. Once you have your equation, you feel so compelled to do something, you have an equation, you must solve it. When you solve your equation, you might land on something like x equals 5. Well, for application problems or word problems, you need to tell me what that 5 means. 5 what? Is it 5 days? Is it 5 feet? Is it 5 miles? 5 people? 5 what? 5 degrees? So when you state your answer, I want you to use the appropriate units. Is it $5? Tell me what your 5 means. $5 feet, $5, 5 miles, 5 what? So make sure you use the appropriate units. And then I want you to ask yourself for step 6. Look at your answer and say, okay, does that make sense? You're going to want to check your answer and really ask yourself, is it reasonable? I had a student solve a problem once, and the problem had to do with the age of the son and the age of the father, and then the two ages added up to some number. Well, the student did his work, got the age, said, I think it was X is 11, and I think the second one was 8. And so what this person was telling me was that the son was 8 years old and the dad was 11 years old. Didn't even stop to think about whether that made sense at all. Totally didn't. Wrote it down, had 2 numbers, was completely satisfied. But I don't want you guys to do that. I want you to look at your answer and ask yourself, does that make sense? Yes or no? Now, we've talked about some of these formulas below in this box, how to calculate distance, some area formulas, some perimeter formulas, but we're going to go through them one more time very quickly. In order to do word problems, it's really helpful to have just a few basic formulas. Calculating distance, calculating area, calculating perimeter are some good basic things to do here. We have the one distance equals rate times time. Again, I know you've seen these, so we're going to go through them fairly quickly. Area of a rectangle is length times width. Area of a triangle is 1/2 base times height. Area of a circle is pi r squared, where pi is approximately 3.14, and r is the distance from the center of the circle to the outside. In order to find perimeter of a polygon, you're going to add all the sides. Perimeter of a circle, we call that circumference. And we use the formula C equals 2 pi r. These three things I know we've talked about. The next three, though, this should be, well, it might be new to you. Let's talk about consecutive numbers. Well, the word consecutive means one after the other, or in a row, you could think of them. So consecutive numbers would be numbers in a row, like 13, 14, 15, 16, and so on. Those are 4 consecutive numbers. Well, what we need to do, if we're working with consecutive numbers, we need to be able to use variables to represent them. If my first number is n, what is the next consecutive number? Or how much bigger is the next consecutive number? So if my first number is 13, the next one is 1 unit bigger, right? If n is my first number, the next consecutive number is n plus 1. The next consecutive number is n plus 2, followed by n plus 3, and so on. So this is how you would write consecutive integers. If we're talking about evens and odds, it's a little tiny bit different. So let's just write down an example of what consecutive evens might look like. 8 followed by 10, followed by 12, followed by 14, followed by 16, and so on. Consecutive odds might be 11 followed by 13, followed by 15, followed by 17, followed by 19, and so on. I want you to look and ask yourself, how much do these numbers differ by? In other words, if my first number is n, how much larger than that should the next number be? Well, what did I add to 8 to get 10? I added 2. What did I add to 11 to get 13? I added 2. So whether we're dealing with evens or odds, consecutive evens or consecutive odds, it's going to start off with n, followed by n plus 2, followed by n plus 4, followed by n plus 6, and so on. This is how you would write consecutive evens or odds. They differ by 2, where consecutive integers, just regular numbers, differ by 1. Okay. Let's talk about complementary angles. This is a geometry term, and two complementary angles, let's go ahead and draw in another angle. I don't like that. I'm going to make that a little bit lower. Okay. Let's say we have, that's better. So if I look at this, for two angles to be complementary, they need to form what we call a right angle. In other words, this angle right here is a right angle, like the corners of a room or the corner of your paper, or how the floor meets the wall. They form a 90-degree angle. And let's say this is x, and let's say this is 2x. 90 degrees is what these would add up to because they are complementary. So I could write the equation x plus 2x equals 90 degrees. So complementary angles form a right angle which measures 90 degrees. Supplementary angles, again, this is another geometry term. Two angles are supplementary if they add up to 180. So let's go ahead and add an angle here. Now I have this angle, let's call it x. I have this other angle here. Let's call that 3x. I know that if I add these two, because they form a straight line, I can say x plus 3x equals 180 degrees. Supplementary angles form a straight line which has the measure 180 degrees. Okay, so there's some background information. We have our 6 steps to solving. We have some background information that's going to help us when we actually work through these word problems. And I'm going to work through a handful of these. And what I'm going to do is I'm not going to focus on the equation solving so much at this point. I really want to practice setting up the equations because that is the trickiest part. Now the first one I'm going to do just deals with translating from words to symbols. So twice the sum of 4 and 3 times some other or some number is 34. What is the number? So let's take a look at this. Twice the sum, this phrase here, tells me that it's going to be 2 times the sum of something. Well, twice the sum, whatever this is on the inside, I'm going to have to double that. And then it tells me what my 2 numbers are. My 2 numbers are going to be 4 and 3. But notice this isn't just 3. This is 3 times some number, so that's actually going to be 3x. So twice the sum of means multiply, right? Oh, I'm sorry. No, ignore that. It's the sum of 4 and 3 times some number. Double means we're going to twice means we're going to times it by 2. Anyway, sorry, I digress. So twice the sum of 4 and 3 times some number, 4 and 3x, is, I know that this means equals 34. Okay, I'm not going to solve it. I want you to solve this one. And bring me the answer. We're going to check it next time we meet. Go ahead and flip the paper over. We're going to do bicycling. After finishing college, Nico spent a week touring Tuscany, Italy by bicycle. He biked 260 kilometers. I'm just going to highlight some pertinent information. I know that the 260 is going to come into play somewhere. From Pisa through Siena to Florence. From Pisa through Siena to Florence. So, let's see, at Siena, he had biked 3 times as far from Pisa as he would then bike to Florence. This sentence right here is a little confusing, so I'm going to come back to that one. How far had he biked, and how far did he have left to go? Now, we've read it. Let's try and draw a picture here. I know that he is on a bike trip. He is starting in Pisa. He is passing through Siena, and he is going to Florence. I know that this total distance is 260 kilometers, right? I get that right here. So I have a picture kind of telling me what's going on, but let's look at this part here that's a little bit tricky. He had biked 3 times as far from Pisa as he would then bike to Florence. He had biked 3 times as far from Pisa as he would then bike to Florence. The thing we have less information about is the Florence part, right? As he would bike to Florence. That's what I have less information about. So that's the thing I'm going to call X. If Siena to Florence is X kilometers, then it says he had biked 3 times as far from Pisa, right? Because he is here. Here's our little man at Siena. He had biked 3 times as far from Pisa as he would have to bike to Florence. So whatever this is, he has traveled 3x. He's traveled 3 times as far as he would have to go to get to Florence. Okay. Question is, how far had he biked and how far did he have left to go? Drawing this picture and putting him in Siena and identifying the thing that I have the least information about helps me get my variable, my picture. And I know that if I take the distance from Pisa to Siena and I add that to the distance from Siena to Florence, it should equal 260 kilometers because that's the total distance. So my equation is going to look like this. The total distance is 260 equals 3x plus x. I would like you to finish this problem, please. Go ahead and solve this and answer the question. And let's go through to the next one, oldest bride. The world's oldest bride was 19 years older than her groom. That's probably important information, right? The world's oldest bride, the bride was 19 years older than her groom. Together, their ages totaled 185 years. How old were the bride and groom? So I asked myself, who do I have less information about? What's going to be my variable? Oh, shoot, you know what? I didn't define my variable up here. Sorry, let's go back up here really quick. We're going to let x equal the distance from Siena to Florence. I wrote it on the picture, but I didn't formally define it, right? I wrote it on the picture so we could see the x covers from here to here, but let's be a little more explicit and state exactly what our variable means. Okay, sorry about that. Back to oldest bride. The world's oldest bride was 19 years older than her groom. Who do we have less information about, the bride or the groom? Well, we know the bride was 19 years older than her groom, but we don't know anything about the groom, so we're going to have the groom be our variable g, and we don't know what the bride is. Well, actually, we kind of do. The bride is going to be 19 years older than the groom. Together, their ages totaled 185 years. So 185 is the bride's age, 19 plus g, plus the groom's age, which is just g. She's older. And we can even write this down. This is the bride, and this is groom. So I'm going to have you finish this one. Let's go on to the next one. The next one is a teeny tiny bit tricky, a little bit. The balance on Will's MasterCard account grew 2% to $870 in 1 month. What was his balance at the beginning of the month? So the balance grew 2%. What this tells me is that the 870 corresponds with a percentage that is 2% larger than the original. Well, if the original is 100%, then the 870 is 102%. So the 870 corresponds with 102% because this is the end of the month balance. This is the end of the month percent. So I'm a big fan of proportions. We have 870, right? We're doing part over whole over whatever the original balance was equals the new 102% over 100%. Right? The part over the whole equals the percent over 100. Now, we can't solve for x. Now, there's two ways. I can either take the reciprocal of both sides, and I have x over, actually this is how I want you to do it. Take the reciprocal of both sides. X over 870 equals 100 over 102. And now we can multiply both sides by 870 to solve for x. There's going to be some long division involved. But go ahead and finish this problem. And if you have questions, my goodness, please ask me next time we meet. I'd love to talk about these with you. Supplementary angles. It says the sum of the measures of two supplementary angles is 180. So this is a little definition here. If the measure of one angle is 3.5 times the measure of the other, find the measure of each angle. Well, I'm starting out with a picture. They're supplementary. They make a straight line. I have two angles. I know one of those is 3.5 times the measure of the other. Do I know how big the other one is? No. So I'm going to call that x. This is going to be 3.5 times x. What do they add up to? Well, x plus 3.5x equals 180 degrees. So they add up to 180. For me, with this 3.5 here, I'm not a huge fan of that. What I would do is I would convert this to an improper fraction. 2 times 3 is 6, plus 1 is 7. I would write this as 7 over 2x. And then because we're adding these, this is really 1x, isn't it? I could rewrite 1 as 2 over 2. Now I have a common denominator, and I can add them to get 9 halves x equals 180, multiply by the reciprocal, and you get the value for x. Okay. Oh, shoot, I didn't do it again. Well, here, x represents this angle, but let's go back up here really quick. What does x represent? Let's define that. Let x equal the original balance on the card. At the beginning of the month is what we're talking about here. Okay. All right. Well, to recap, I have done the problems on the left-hand side. I've set up the equations at least. I'd like you to finish the equations on the left-hand side of the paper. And I'd like you to write the equations for the right-hand side. You don't have to solve the ones on the right, but please practice setting those up. And then if you could also practice this translating one on the front left, that'd be fantastic as well. And I think that is going to conclude our integrity business for the day. Thank you so much, and I will see you soon.